Hi there. So I got your questions about lesson 10 at 10.1, 10.2, 10.3. So I went through and looked at which workbook questions you missed. And so I just thought we'd do a few of those and see if that helps you. So I just copy and pasted them here into this document. So here's the first one. A rocket launched into the air. The height h of t in yards of the rocket is a function of the time t in seconds shown in the following table. Okay, so after this many seconds, here's how high the rocket is. What is the rocket's average rate of change from 3 to 6 yards per second? Okay, so from 3, here's the time of 3. It was 33 feet in the air. And at the time of 6 seconds, it was 0 feet in the air. So it had come down. So it went from 33 to 0. So I want to subtract those because I'm trying to figure out the difference here. So 33 minus 0 would just be 33. And then you're going to divide by how many seconds that was. That's how you find the rate of change. So it changed by 33 feet, and that was over 3 seconds. So 33 divided by 3 seconds. So I would get 11. And so this is the answer. You had 3. So 3 is not correct. It should be 11 because I subtracted the difference. So that's 33. And then I divided by how many, the difference of the time here. So from 6 seconds to 3 seconds, that's 3, a difference of 3. So 33 divided by 3, you get 11. Let's look at this next one. Okay, so examine the following graph of the nonlinear function. So we have this. What is the average rate of change over the interval 1 to 3? So when x is equal to 1, all the way until x is equal to 3. Okay, so my x values are here on the x-axis. So I'm going to find where x is 1. So that's right here. So I have this point, 1, negative 2. And I'm going all the way up until x equals 3. So I'm going to go up to this point. Okay, so I'm looking at from x equals 1 to x equals 3. What's the rate of change? So when x equals 1, the y value was negative 2. And when it equaled 3, the y value was 4. So I'm changing from negative 2 to 4. So I want to figure out the difference there. From negative 2 to 4, that's a difference of 6. I went up 6. So that's the first thing you're going to subtract 6. And then how many points was that? I went from 1 to 3. So that was a change of 2. Okay, so I went up 6 over the course of 2 x values. So I need to do 6 divided by 2. So 6 divided by 2 is 3. So this was the answer. You had 6. So I'm guessing you realized that it went up 6, but it also went over 2. That was over 2 points. So you need to divide the 6 by 2. Okay, so hopefully that makes sense. Rise over run. They've talked about this a lot in this course. So rise, you went up 6 and over 2. So 6 divided by 2. Okay, let's look at this next one. Down here. Okay, so James is contemplating an investment opportunity represented by the function a of t equals p times 1.06 to the t, where p is the initial amount of the investment and t is the time in years. If James invests $5,000, what is the rate of change in dollars per year, rounded to the nearest dollar, between years 15 and 20? Okay, so we're going to use this formula. The initial value is 5,000, so you're going to put 5,000 right here. And then you have times 1.06 to the t, which is years. And we're looking for years 15 and 20. And we're going to find the difference between years 15 and 20. So you can use any calculator. I like this desmos.com if you've never used it. It's just handy and it's right there on your computer. So the first thing I'm going to do is find on year 15. So I'm going to go 5,000 times 1.06. And then there's this keyboard button here at the bottom. Sometimes it's hidden, so you just click right here. This allows you to do any exponent. So I'm going to use this button right here to do any exponent, and I'm going to do the exponent of 15. And so there's my answer right there, 11,982 point, all this stuff. Okay, so that's year 15. Now I'm going to do the same thing for year 20, 1.06, and I'm going to do the exponent of 20 for year 20. So that gives me this number. Okay, so if I want to find the rate of change between years 15 and 20, I first need to subtract these two. Okay, so I'm going to go 16,035.677 611. I probably don't have to go that many decimal places. And I'm going to subtract this one up here. 11,982.7909655. Okay, so here's the difference. So that's like my rise. I went up by 4,000, but over how many years? From years 15 to 20, that was over the course of 5 years. So I need to divide this number by 5. Okay, so 4,052.8863956 divided by 5 years. So I get 810.577. And I think it said round to the nearest dollar, round to the nearest dollar. Okay, so then 810.5, that means I'm going to round up to 811. So the average rate of change between those years is 811. And let's see, you had 799. So you were kind of in the ballpark, but still not right. So those are the ones you've missed so far. And I believe you haven't done the workbook on 10.3 yet. So you might want to go try that. So then at least I can see which questions you got wrong. 10.3 has a lot to do with intervals like this, finding the rate of change over an interval. So let me just give you a quick little overview of intervals, and maybe that will help you. So when like this says x is greater than or equal to 1 and x is less than or equal to 3. So first you need to know you're on the x-axis. You're finding when x equals 1 right here, all the way till x equals 3 right here. And then you're just going to find the rate of change between those 2 points, this point here and this point here. And you can just count the rise over run. How much did you go up? How much did you go over? And you're going to divide those numbers. Sometimes it goes down, the rise could be down and then over, like a negative and over. So maybe just if you could try to do the 10.3, and then I can see which ones you missed and make videos based on that.